Hey, it's Dr. Pat again, and we're looking at our last example here of rates of change. We're looking at the formula version of how to calculate rates of change. Okay, just remember, slope, rates of change, same thing basically for us. And then the calculation for slopes is this whole function notation, f parentheses x2 minus f parentheses x1. So that's just basically our function notation way of saying the y value. So this is the same thing as saying y2 minus y1. It's just that you have to do the extra step of plugging in the x value and then calculating the y value. So just keep that in mind. We're going to have to do the extra step. It's a little bit more, more work than a graph, because a graph we can just read the y value. We're going to have to calculate the y values. Okay, so when we're playing with this rates of change, here's the function I want to play with. Just a nice example, 11x squared minus 7. And these are the three things I want to look for. Okay, so I want to look for the average rate of change over the interval 2 to 5. Just a reminder, when we look at something like this, interval 2 to 5, these are x values. This is not an xy. This is an x beginning x and a ending x, or our x1 and x2. And then what we're looking for is we're looking at the average rate of change at x equals 4 with an interval of 3. Please notice, this time I did not give you the beginning and the ending x. I gave you the beginning x and then the interval size. Interval size is the change of x. And then the third one, is find the overall rate of change at x equals 0. And on that one, I only gave you 1x. So how are you supposed to find a slope when I only give you 1x? Well, the key on that one is going to be the word overall. So just got to be thinking about that. All right, so let's get into our examples here. All right, our first one right here, average rate of change. We're going to take that 5. We're going to plug it into the formula right here. We're going to take that 2 and plug it into the formula. So that's what we're doing. We're taking the 5. Those are the x values. We're going to plug them into that formula. I'm going to get 268. Take 2, plug it into this formula. Going to get 37. We take the differences of those y values over the differences of the x's, and I got a slope of 77. Okay, my rate of change is 77 first units over the second unit kind of idea. So first unit per second unit. So that's our calculation for slopes. When given a function, it's the extra steps of plugging in the x values to find the y values. Now for the second example that I have here, I have a beginning x value, it's 4, and I have an interval size of 3. And so here's my setup for this one. You're going to see here I'm starting at an x value of 4 plus my interval size. Well, that's going to get me 7. Okay, so that's really meaning another way of saying my ending value or my ending x value, my second x value is 7. My first x is still 4. So we're going to plug in 7 into this formula. Going to get 532 when I do that. Going to plug in 4 into this formula. Going to get 169. Then I take the difference of those and divide by 3. Please notice, when you're playing with the intervals, your denominator is automatically that interval because the change of x's is the interval. Interval is the change of x's, so I automatically have in the denominator my 3. Just crunch it all out, divide, and I get 121 for my slope for my rates of change. The last example I'm looking at is was the average rate of change from time 0. That was the overall, so that's the key. When you see the word overall, that's basically meaning you're starting at time 0. So I'm starting at x equals 0 is my first x value, and my second x value was the one I was given, and that was the 6. So the word overall that we saw on the previous screen, that is just basically meaning starting from 0. So I plug in 6, I plug in 0, I do the calculations, get a y value of 389 when I plug in 6, get a y value of negative 7 when I plug in 0, take the difference of those two, and then divide by 6, and I get the answer of 66. So that's how we do average rates of change when using a formula. Okay, so it's just the calculation of slope. You just got to plug in the numbers into the formula, calculate to get those y values. That's the extra work that we have to do. A little bit different than graphs and tables, because graphs and tables, we can just grab those y values. Here, we got to calculate those y values. So that should do it. Take care, have a good one, and I hope this helped.